Hello students, welcome back. Let us resume our discussion in section 3. Previously we talked about logarithmic differentiation, but only for type A problems. Some humongous product or quotient or both. How do we handle the logarithmic differentiation here? Step 1, take the log and then simplify. How do you simplify? Use the log rule. Everything in the numerator means their multiplication, so by the log rule they become addition. Therefore they have positive signs. And then all the factors in denominator, those are divisions, so they become subtractions, therefore they have negative signs. So everything in the numerator, positive, everything in the denominator, negative. And then bring down all the powers to coefficients. Now you're ready. Take the derivative. Left hand side y prime over y as usual, and in the right hand side just take the derivative of each logarithm. Everything, all the inside goes to the denominator, and then don't forget to multiply the derivative of the inside. And then flip the denominator to the other side, you get the answer. But this is not the best because this is an x expression, and this is just y. They don't mix. So let's go back to the original problem and then replace y by this. And then you get the final answer. This time, everything on the right hand side is an x expression, so everything looks good. So this kind of technique is called the logarithmic differentiation. Take the log, break apart, simplify, take the derivative, flip the denominator, and then rewrite y. But then again, this kind of problems had alternative method, the generalized product rule. Bring up the denominator by taking the negative power, and then apply the generalized product rule. We have 4 factors here, so 4 bunches have to be added. They all have to be the same, except the first factor becomes its own derivative, second factor becomes its derivative, third factor, and the fourth factor, like that. If you have 5 or more factors, just repeat that process. Cumbersome but straightforward. So comparatively speaking, which is better? The generalized product rule, in my opinion, is easier to apply. So there is relatively little motivation to learn and study this logarithmic differentiation, even though our textbook author prefers it and then sometimes requires it. But then again, if you go over to the next class, you'll begin to appreciate the logarithmic differentiation method. How do you handle this kind of problem? Alright, that's where log differentiation shines. Why? Let's copy this problem here. Okay, alright. There. Step 1, take the log. So what do you have? Log of x to the log of x power? Is that it? Let's see, this is x to the log of x power. So this is x, and then this is log of x, the power, the same thing. And then use the log rule. The power comes out as coefficient, so log of x times log of x. And this log of x came from the power, and then this one, original base. See the color coding? Does it help? Do you see which one came from where? So y equals x to log of x power. Take the log. Log of y is log of x to log of x power. And then log of x comes out. We get log of x times another log of x. So log of x squared. Okay, alright, we are ready. Let's take the derivative. What do you get? Oops. As usual, you're going to get y prime over y in the left-hand side. Or if you prefer, you can take the derivative implicitly, 1 over y, and times y prime. Either way, it works out. You see? Whenever you take the derivative with respect to y, y prime pops up. That's the nature of the implicit differentiation. Now, how about the right-hand side? Well, it's a chain rule. 2, subtract 1 from the power, and multiply the derivative of the inside. Alright? What's inside? It's log of x, and then nothing changes inside. Instead, you have to multiply the derivative of the inside. 1 over x. Are you satisfied with this differentiation? Let's simplify it just a little bit. 2 log of x over x. Alright. Okay, alright, we're almost there. We want y prime, as highlighted in red. So flip this y to the other side and you'll get the answer. Y prime is equal to y times, and let's take a little bit of font again. Two log of x over x. But then again, what is y? Y is x log of x. So this entire thing is x log of x times 2 log of x over x. That completes the problem. So take the log and simplify using the log rule. Okay? And then to take the derivative. Left hand side is y prime over y as usual. Right hand side is the derivative of this expression using the chain rule and whatever. And then flip the denominator to the other side and replace y by the original expression. Typical log differentiation, but this time it really shined. Whenever you have arbitrary base, not just constant base, but variable base and variable exponential, think about log differentiation. There is an alternative method, but most of my students prefer log differentiation. That was my experience actually. Let's do this one more time. This time, let's go ahead with this problem. It's going to be a little bit harder because the base is a little bit more complicated. And let's put some space in between there. Okay, alright, that looks a little bit better with some margins and spaces. Okay, what is log of y? That's log of this, of course. Yes? And that's nothing more than the log rule. The power comes out as coefficient, and log of x. Does everything look okay? Let's see, here log of x is the base, highlighting in green. Oops. Oh, come on. Sorry about the typo. And then cosine of x to the power, highlighted in purple. So here, log of x, the base, and cosine of x is the power. And then using the log rule, power comes out as coefficient, and then this one stays where it was. And then this logarithm here came from taking the log. So this log and that log are different. But of course, in the end, we have log of log. Alright, now let's go ahead and derivative computation. Y prime over y as before, as usual. And you're looking for y prime, of course. Let's highlight it in red. That's the quantity you're looking for. Or you can write it as 1 over y prime times 1 over y times y prime using the implicit differentiation. Either way, it works out. How about the right-hand side? What do you see? Do you see a product rule? Product of two functions, cosine of x times log. So derivative of first function, and then the second function. and then the first function, and then the derivative of the second function, and oh boy, this is going to be a chain rule. We have a composite function, log of x. Okay, let's go ahead with its chain rule computation. Outside first. Reciprocal, so 1 over whatever the inside. Are you with me here? Inside is log of x. Now you have to multiply the derivative of the inside. What's the derivative of this inside, log of x? Maybe I should be keeping this color coding still. Well, that's 1 over x. See that? Okay, we're almost there. We want to find out y prime. Okay, let's go ahead and find out y prime. It is y times this thing, negative sine of x times log of x cosine of x times 1x log of x. I just rewrote this. Okay, one more. What is y? Let's copy and paste. What is y? It's here. Log of cosine of x. And that'll complete the problem. So log of cosine of x, original y, times the product rule computation. Product rule and then chain rule computation. It was much harder, wasn't it? Anyway, these are log differentiation problems when both the base and power are functions. Let's see, that's one way to handle it. But we have an alternative solution as well. An alternative solution is based upon the change of base formula. Let me show you. What is the change of base formula? It's this. A to the b power is the same as e to the b times log of a. So if I use that, then I can change any exponential into natural exponential, and the base becomes log of x up there. In the end, we have e to the log of x squared over there, and then we can go ahead with the derivative computation. Exponential always stay the same, and then by chain rule, we have to multiply the derivative of the inside. What's the derivative of the inside? Another chain rule. 2 comes out, subtract 1 from the power, so just first power, and then the derivative of the inside, 1 over x, the same computation we did before. And as for these, simplification is not really necessary. You can if you want to, but it's not necessary. Which method do you like better? Me personally, I like the change of base formula better. Most students, as a matter of fact, preferred logarithmic differentiation in my experience. The reason, the change of base formula is shorter and elegant, but the trade-off is each step is that much more condensed, more complicated. Logarithmic differentiation, on the other hand, is longer, it has more steps, but the trade-off is each step is simpler. Let's see, do we have enough time for the change of base formula solution for the second problem here? Okay, kind of like that. Change of base, e to the cosine of x, log, and then the base, so log x. Take the derivative, exponential always is the same, and then up here use the product rule and chain rule. And that's it. These two here are unnecessary. So it's a two-step problem. Simpler, but each step is that much harder.